Another session on Laplace transformation. So today I believe we are going to be looking at another session, which is our sixth session on Laplace transformation. So basically, on our last video, we treated Laplace of a hyperbolic function, right, which is the sine. So we treated the Laplace of sine at, right, and we said it's equal to what? A divided by s squared minus a squared. So today we are going to be treating another similar expression, but in this case it's the Laplace of cosh, which is another hyperbolic function. So I believe you understand how it got this particular expression, which we are going to make use of the same process we use in deriving this one and use it in deriving the cosh. So now basically today we are going to be treating the Laplace of cosh at. So today we are going to be treating the Laplace of cosh at, if you don't know, right? Now remember I said before I started proving this on our last video, I gave an expression. I said the sine of 80 is equal to the 1 over 2 times exponential of 80 minus exponential of minus 80 and so on and so forth. So now the same thing goes for cosh 80. Cosh 82 also has its own representation, also has its own expression. So the expression of cosh 80, given that cosh 80 is equal to 1 over 2 in bracket exponential 80 plus exponential minus 80. So this is the expression for cosh, 1 over 2 times exponential 80 plus exponential minus 80. So now, before we proceed, cosh 80, right? 1 over 2 times exponential 80 plus exponential minus 80. Now this is the representation of a hyperbolic function. This has been derived. It's not something that was made up. It was derived from the series of hyperbolic functions. So you can now see, look at how they derived it, but I don't think that's necessary. But because you just need to know this particular, that this is equal to this and that's one. So now we're going to be using this to get the Laplace of cosh 80, right? So now, like I said, the general expression for the Laplace of a function of t is always, I'm always trying to remind. So now let's see the general expression for the Laplace of a function of t. So I believe I've been treating this based on or sequentially based on the videos I've been doing. So I said Laplace of a function of t is equal to the integral starting from 0 to infinity of a function of t times exponential minus st dt. Right? This is the Laplace of a function of t. Now if you have noticed that all the answers we have been getting based on our last videos are always in the function of s. Like our first video, we said the Laplace of a is equal to a by s. A, which is a constant, and s is a variable. So we are getting all our answers in functions of s. For example, given the last video we did, we said the Laplace of sine 80 is equal to a divided by s squared minus a squared. You see that a here is a constant, which is a figure, but s here is a variable. So you see all the answers we have been getting are always in functions of s. So we can say the Laplace of a function of t, which is equal to this, will eventually give me a function of what? S. So will eventually give me equal to the function of s. So I forgot to treat this on the introduction of Laplace transformation, but I believe it's understandable because you can actually relate it based on the previous videos I've been doing, that all the answers we have been getting are always in function of what? S. So now let's continue. So the Laplace of a function of t, we are going to be using this. We're going to be getting the Laplace of cosh 80 using this representation and using this. So Laplace of cosh 80 is equal to the integral starting from 0 to infinity, right? Now we said cosh 80 here. Instead of us representing cosh 80, we can say cosh 80 is equal to what? 1 over 2 times exponential 80 plus exponential minus 80. So putting this in this, we have 1 over 2 open bracket exponential 80 plus exponential minus 80 times exponential minus st dt. So now let's proceed. So now given this, so like I said, I've replaced cosh 80 with 1 over 2 exponential 80 plus 80 exponential minus 80 times exponential minus st dt. So now this is what we have. So now before we apply our limit from 0 to infinity, we need to integrate. So integrating this first, we will be having the integral 1 over 2 open bracket exponential 80 plus exponential minus 80 times exponential minus st dt, right? So now let's simplify it before we apply our integral sign, before we integrate it. So taking the constant to the back of the integral sign, we we're having 1 over 2 integral exponential at plus exponential minus at times exponential minus st dt. So we can multiply through by exponential minus st. So by exponential minus st times exponential at, I explained in the previous video that the exponential of m times the exponential of n is equal to the exponential of m plus n. So exponential of at times the exponential of minus n. So multiplying through, we'll be having 1 over 2 integral exponential at times exponential minus st plus exponential minus at times exponential minus st dt. Right? So now simplifying this, we'll be having 1 over 2. Now this exponential at times exponential minus st is equal to exponential at minus, because it's equal to exponential at plus minus exponential minus st. Why? Because I said exponential of m times exponential of n is equal to the exponential of m plus n. We are following this rule, so I'm going to be applying this rule here also. The exponential of at times the exponential of minus st, due to this minus, so it's going to be integral of exponential at minus st plus exponential of minus at times the exponential of minus st is equal to the exponential of minus at plus minus st, so which is exponential minus at minus st dt. Right? So now we're going to be integrating. Before we integrate it, let's simplify it in a more simpler term. So let's simplify their powers. So taking s to this other side, taking a to this other side, we'll be having 1 over 2 integral exponential minus st minus at plus exponential minus st plus at minus st minus at with respect to dt. Right? I just change the position of s and a, then this is what I have. So now let's continue. So I change the position of s and at, right? Change the position of s and change the position of at, right? So now let's continue. So now let me simplify minus sign outside of this power. So we'll be having 1 over 2 open bracket exponential. Now taking minus out, I'll be having minus open bracket s plus minus open bracket s minus at minus a. Taking factoring out t also outside, so we'll be having t plus exponential. Taking out minus, we'll be having minus s minus a. Plus a, because minus times plus becomes minus, right? And factoring out t, I'll be having t, right? So with respect to the t. So then I can integrate it. So integrating this, we'll be having 1 over 2 open bracket exponential minus s minus a t divided by minus s minus a, right? Plus exponential minus s plus a t divided by minus s plus a. So now remember the actual question says the integral coming from 0 to infinity of cosh at, right? Times exponential minus st. So that means we are applying our limit from 0 to infinity. So applying our limit from 0 to infinity, right? So now let's work this out. So taking our limit to infinity and taking our limit to 0, right? So we'll be having limit t to infinity, right? Now taking the constant at the back of the integral sign, so we are at the back of the limit sign, so we have 1 over 2 limit t to infinity of this, right? Of exponential minus s minus a t divided by minus s minus a plus exponential minus s plus a t divided by minus s plus a minus limiting t to 0, we'll be having exponential minus s minus a t divided by minus s minus a plus exponential minus s plus a t divided by minus x plus a, right? So we're limiting t to infinity, we're limiting this to infinity and limiting this to 0, right? So now let's proceed. Continue from where we stopped, right? Continue from where we stopped. So I said limit this to infinity and limiting also this to 0, right? So I've splitted it out for you to understand. So we're going to be limiting t to infinity of this. So anywhere I see t, I'm going to put infinity, right? So if I put infinity here, exponential of infinity, so infinity times this becomes infinity, right? Infinity times 1 is infinity times anything is infinity. So putting this to this, so infinity times everything becomes infinity. So exponential of infinity is eventually 0, right? In fact, so limiting t to infinity of all this, anywhere I see t, I put infinity, becomes what? 0. So I'll be having 0, right? Minus limiting t to 0. Every I see t, I put 0. Right now, this can actually give us a very definite figure, so, right? So now let's input t to 0 here. So this we will be having any I see t, I put 0. So this is exponential minus s minus a times 0, right? Divided by minus s minus a plus exponential minus s plus a times 0 divided by minus s plus a. So 0 times minus s plus a is eventually 0. So exponential of 0 is 1, right? So we'll be having, don't forget this is my fraction here. So this is 1 over 2. So 1 over 2, open bracket, 0 minus, so you'll be having 1 over 2, right? Open bracket, 0 minus. Now anyway I see, now this is exponential, minus x minus a times 0. So this is 0 times this is eventually 0, right? So this is open bracket, exponential 0 divided by minus x minus a, right? Plus 0 times this is also 0, right? So this is exponential 0 divided by minus s plus a. Exponential 0 is what? 1, right? So this is 1 divided by 2, open bracket, 0 minus 1 divided by 1 minus x minus a plus 1 divided by minus s plus a. So now if I multiply through by minus sign, what will I have? So multiplying through by minus sign will be having, so continuing from where we stop, right? So multiplying through by minus sign will be having 1 over 2, open bracket, minus times this, minus cancel minus that, or minus times minus is plus, right? So we'll be having 1 over s minus a, 1 over s minus a, minus times this is plus, right? But minus times this is minus, right? And minus times minus is plus, right? So we'll be having plus 1 divided by x plus a. Then the minus a, minus times plus is minus, minus times minus plus. So we're having this, right? So multiplying through by, or before multiplying by 1 over 2, right? So now let's take the LCM of this. Taking the LCM of this, s minus a, s plus a, right? So s minus a in s minus a, s plus a in s minus a will be left to just s plus a, right? S plus a times 1, that's s plus a, plus this in this, that's this will cancel out this, so remaining this s minus a times 1, that's s minus a multiplied by 1 over 2. So eventually a will cancel a, right? So we are left with 1 over 2, open bracket, x plus s, that's 2s. So we have 2s divided by, now this is what we call difference of two squares, right? So when we expand this, s minus a times s plus a, when you expand it, expanding it meaning x times s, that's x squared, s times this, that's this. So now to expand, so expand this will be having x squared minus a squared, right? So we know that 2 will eventually cancel out 2. So our answer is left with s divided by s squared minus a squared. So you see that this is another function of s. We started from a function of t, which is cosh 80, and we are arriving at a function of s, which is x divided by s squared minus a squared. So you see the Laplace of every function of t will arrive at a function of what? S. So this is our answer. Now let's take some examples. Guys, as I was saying, so before we take an example, we still want to revise what we just did. So we got the Laplace, we calculated the Laplace of cosh 80. Now a can be any number, can be any figure. It can be cosh 3t, can be cosh 5t. A is a constant which can represent any number or any figure. So cosh 80 now, which we've got s divided by s squared minus a squared, right? So basically Laplace of a function of t will eventually give me a function of what? S, right? So all the Laplace questions we have been deriving lately based on our last video up to this point are always in function of s. So basically, Laplace of a function of t will give me a function of what, s. So now let's take an example. So an example. For instance, you're asked to derive or calculate the Laplace of cosh 5t. Very easily. So we compare this with this. What's my a? So when I compare cosh 8t to cosh 5t, what's my a? My a is what? 5, right? So now, since my a is 5, then I'm going to apply my formula. So the formula of the Laplace of cosh 8t is equal to what? S divided by s squared minus, now since a is 5, right, so we'll be having 5 squared, right, so which is equal to s divided by s squared minus 25. So you can try out other exercises from I'm going to recommend a particular textbook. Looking down, I'm going to recommend a particular textbook, so you look down on the description below. I'm going to drop the name of a particular textbook you can actually use to learn the Laplace, to get other exercises from this question. So I'm going to drop a simple exercise for you to practice through. So I want you to derive the Laplace of cosh 3t. So I want you to do this exercise, and you comment your answer on the comment section below. So thank you for watching. Please and please subscribe.